This is a digital logics question based on number system representations. We are having a 2-byte unsigned integer that is being represented on two different computers, in which one is following the Little Endian format while another one is following this Big Endian format. And what they're saying, the numerical value of that integer on Little Endian is 255 more than that on the Big Endian computer. So first let us understand what do we mean by this Little Endian and Big Endian. Let us say we have this integer ABCD. Let us consider only 1-byte integer. So these are 4 bits, 4 separate bytes making up an integer. So if it is represented on a Little Endian and Big Endian, how would it look like? We know that in the Little Endian, the most significant byte, which means this A, that would get the lower address, which means it would come on the rightmost extreme. So this number would be represented as A, B, C and D from right to left. The MSB gets the lower address, while in Big Endian it is in the usual format as we have. The MSB gets the highest address, so this number is from left to right. So that is how the representations differ, just in the way we read the integers from left to right or right to left. That is the only difference. But here they are saying that between these two numbers, which means if this DCBA is interpreted as a different integer itself, then this DCBA should be 255 more than the corresponding value of this ABCD. This particular property must be followed. That is what the question is saying. And now from the given options, we have to determine that which of these are the valid representations of unsigned integer on a Little Endian computer, which means considering these all options to be the corresponding Little Endian representations, we need to check if they are valid or not using this particular property, that the difference is 255. So how will we approach this? Let us first note down all these numbers in their corresponding Little Endian and Big Endian representations. So for the first one, Little Endian is given as 6665. But another thing to note over here is the integers here are 2-byte unsigned integers, which means these 2 bytes put together, they would be considered in pairs. So we cannot simply reverse as we did for this number. It was ABCD, so we simply reversed it into DCBA in order to convert it from Big Endian to Little Endian or vice versa. Here we cannot simply reverse, we will need to reverse in pairs, just because integer is occupying 2 bytes. So for this, if this is the Little Endian, then we will have to reverse it to get the corresponding Big Endian, and that reversal would be done in pairs in this particular way. 65 will come first, all of them put together, they won't be separated, and then this 66 would come. So this is how the reversal takes place. So that is its corresponding Big Endian representation, 6566. Similarly for the next one, it is 0001. Again they will be reversed in pairs, giving 0100. For the third one, it's 4243, which would become 4342. The last one, that is 0100, becomes 0001. So now we have got the corresponding Little and Big Endian representations, but we don't know if all of them are valid or not. So how will we do that? We will check if their difference is coming out to be 255 or not. And all of these numbers are represented in the hexadecimal format. So their difference, this is actually in decimal itself. If we are considering the hexadecimal, then this 255 of decimal will correspond to FF in the hexadecimal. So we have to check if the difference comes out to be this FF or not. So let us subtract them one by one. The first one, that is 6665 minus 6566. Let's see. Now this 5 minus 6 is not possible, so we will make it 5 plus 16. This will become 5. So now when we subtract this one, that will give 15, and 15 is nothing but F. Again, this 5 minus 6 is not possible, so this becomes 5 and 16 adds over here. So again 16 plus 5, 21, minus 16 is minus 6 gives 15, which is F. Then 5 minus 5, 0, and 6 minus 6, 0. So yes, it is giving FF. Means this particular property is being followed over there. So that is a valid number representation in a Little Endian computer. Let us go for the next option. Little Endian is 0001 and Big Endian is 0100. Now here you can see the lower number is greater, so this is going to be in negative. So that definitely is not possible, but let's try to do it in this way. 0100 minus 0001. Here this becomes 0, then this becomes 16 and 1 will be given there, so 15, and then this gets 16. So this is 16 minus 1, 15, that is F. This is also F, 0, 0. So this is actually giving us minus 255 because the Big Endian number is bigger in case of this particular option. The Little Endian is smaller, so this would be incorrect. Similarly, coming to the third option, here also we can see the Big Endian number is bigger. So this may also give, if you try to check out, it will also give minus 255. So this is also eliminated. Then coming to the last one, that is 0100 minus 0001. That is the same thing which we had done over here, and it turned out to be FF, which means 255. So this one would also be correct. The Little Endian minus Big Endian is giving FF correctly. That is what we wanted. So for this question, the correct options would be A and D.